Look at the deep gradients and crashing white waves in this epoxy floor. It tricks your brain into thinking the solid ground is actually moving. But when most beginners try to recreate this, they often get the result on the left. The white foam spreads too evenly, the colors mix into mud, and the floor looks like spilled paint instead of natural water. The difference between that flat mess and realistic ocean depth comes down to a specific technique called wave lacing. Wave lacing is controlled chaos. It relies on a precise chemical reaction between heat, movement, and epoxy density, all triggered at an exact moment. The realism of the wave is a result of fluid dynamics and timing, not manual painting. The process begins by mapping out visual depth. You start by pouring the darkest shades of navy epoxy as far from the intended shoreline as possible. From there, you blend progressively lighter colors toward the edge, moving from deep teal down to translucent aqua. This specific dark to light gradient tricks the eye. It forces the brain to perceive vertical drop-off and distance on a perfectly flat concrete floor. Once that gradient is set, you disrupt it by laying down a thick, harsh line of dense white epoxy directly along the light aqua edge. At first, it looks completely unnatural. The white is thick and heavy, which often causes beginners to panic and try to blend the colors together by hand. But the white epoxy is not supposed to look like a wave yet. It is the raw, unactivated fuel for the chemical reaction to come. Step 2 is timing. You have to wait until the epoxy reaches a consistency that is fluid enough to move, but thick enough to hold its shape. This diagram shows why timing is binary. Heating too early causes the dense white pigments to sink and disappear into the blue layer. Heating too late prevents the cells from opening as the material becomes too rigid. In this clip, you see the catalyst. You take a heat gun and sweep it at a precise angle and distance across the thick white edge. The heat from the gun is not drawing the wave, it instantly reduces the surface tension of the epoxy. With surface tension reduced, the lighter white pigments expand and stretch outward over the denser blue layers, creating hollow, lace-like cells. Simultaneously, the physical airflow from the heat gun pushes the reacting material forward, simulating the natural directional momentum of a crashing wave. These seafoam patterns are entirely dependent on hitting this intersection of temperature, airflow, and fluid dynamics. Immediately after heating, the biggest challenge for a beginner is the urge to keep overworking the surface. Continuing to touch, drag, or manipulate the wave with tools destroys the delicate cellular structure and ruins the illusion of nature. You have to apply the rule of restraint. Step back and allow the chemical reaction to continue expanding and settling on its own. Once the design is fully cured, the final phase is the application of a clear protective topcoat. This layer is a functional necessity, protecting the intricate artwork from UV exposure, surface scratches, and daily wear. Beyond protection, the topcoat provides the final optical effect, a permanent, high-gloss shine that locks in the appearance of wet water. In this final cured environment, you see how the gradient, lacing, and gloss create the illusion of moving water across the room. Because humans respond instinctively to the patterns of moving water, these floors often change how a person perceives the space they're standing in. Creating this effect isn't about mimicking waves with a brush. It's about engineering the chemistry, mastering the exact timing, and applying artistic restraint. Mastering wave lacing allows an installer to use chemical reactions to create a surface that mimics the physical movement of the tide. If you want to see more advanced technique breakdowns, make sure to subscribe. And let us know in the comments what flooring style we should decode next.